Hello and welcome back to Math 71. This is Mr. Wakefield. We're going to be looking now at section 6.6. Yes, we did skip section 6.5. That's why we're now at 6.6 now. Don't worry about 6.5 at all. 6.6 though talks about not just equations, and we've seen these one variable equations before. All right. We've seen linear equations, all right, where if after you clear out the parentheses, you have polynomials on both sides, and you just have x's and not x to the second or x to the third, but just x, all right, that's called a linear equation, and that had a certain method that you had to use to solve that right here, this four-step method, which we've done a number of times. We also had, though, when talking about one variable equations, where after you clear out the parentheses, okay, such as here's a good example, even after you clear out the parentheses, you now have a polynomial on both sides, but the difference is that now you have not just x, but x to the second is the largest exponent for x there. When you have that in a one variable equation, that is called a quadratic equation, and we had a method for solving that, which was different than the linear method that I just reminded you of just a moment ago here on that other sheet right here. Okay, we have this method for linear. We have a different one for this. It involves factoring and whatnot. Okay, now here today though, different kind of problem entirely, but we're going to eventually be able to transform each one of these equations into either a linear or quadratic equation, which will then allow us to finish off the problem by doing one of those methods, either the linear method or the quadratic method. Okay, the reason why we got to do something first before we transform it into a linear or quadratic equation is because, first of all, when you have fractions in your equation, which all of these do, and not only that, but you have a fraction with a variable in the denominator, which you can see that all of these equations do, all six of them on this page, that means that we have to clear out it. There's more than one way to solve these types of things, but the most common way, which I'm going to do here, is to multiply both sides of the equation by the least common denominator, which we learned about earlier in this chapter, how to figure that out. You multiply both sides by that, and that will transform, if you do it correctly, into, again, either a linear or a quadratic equation. All right, so let's get started here, and we'll do that on each problem. We'll multiply both sides by the LCD. What that does, if you do it correctly, is it will get rid of the fractions. And it's at that point that it will also look like either a linear or a quadratic equation. All right? So let's do that. You'll see here that in this first problem we have two denominators. So the LCD, because of the fact that the denominators are both the same, the LCD, when your denominators are the same, is just that same thing, x minus 5. Now I want to talk about how we're going to multiply both sides of the equation by that. What does that mean in this case? Well, when you have just a term, not a fraction, but just a term and a fraction next to it with either a plus or minus in between it, that means to multiply both the term and the fraction by the LCD, keeping the minus sign in between those two multiplications. So let's write that out here carefully. So I want to multiply 5 times the LCD. Put the LCD in brackets because it's got more than one term and you're multiplying it by something other than 1, so you got to do that. Another thing I want to remind you of as well, put the LCD, yeah, we did that already actually, we put it in brackets, but when you multiply a term times a bracket, you guys, always put the single term in front, because that way we can distribute like we normally do, and we'll be used to doing that, and it won't look weird and all that. Okay. Bring down the minus in between that there. Right there. And then when you multiply the LCD by a fraction, what I want you to do is I want you to also make the LCD into a fraction like this by putting it over 1, and then multiply by that fraction that we're supposed to multiply by right there. Okay. We'll get to that in just a moment. So we have a couple of multiplications here with the minus sign in between it. Bring down the equal sign in the normal place right there. And then when you have just a single fraction on one side of your equal sign, just multiply that fraction by the LCD like this. Again, making the LCD into a fraction also, we do that when we're multiplying by another fraction. Like this, okay? So I've got a total of what? I've got a total of 3. Let me just highlight them for you. You don't have to circle these. I'm just doing this to help you see what I'm thinking here. All right. Now, I now need to figure out what these 3 multiplications in the 3 red circles are equal to. Once I do that, you guys, I will then have either a linear or quadratic equation, and then I can solve it accordingly. Let's find out what happens. If you have just a term times a bracket, no fractions or anything, you can go ahead and just distribute that out. Okay, right now. Bring down the minus again. Now, in this part right here, don't incorporate the minus into this, by the way. Keep that separate. All right, but when I have these 2 fractions being multiplied together, we know how to multiply fractions together now, don't we? All right, we have to identify our factors if any of our numerators or denominators have more than one term. Okay, so I've got a couple of prime red factors right there. I have a couple of green factors right here, 2 and 1. Does anything cancel based on what you see right there? Yeah, the x minus 5 and the x minus 5 cancel, right? And we end up getting what here? We end up getting 1 times 2 over 1 times 1. And that, of course, is equal to 2. All right, 2 over 1, same thing as 2. All right. Bring down the equal sign. And then we do the same thing here. We have what? We have, again, since we're multiplying these fractions together, I have to identify my factors just to make sure that I'm canceling the correct things. All right. And what cancels right there, you guys? The x minus 5s do. All right, because they're exactly the same. If I multiply those fractions together now after canceling, I get 3 over 1, don't I? Which, of course, is equal to 3. And you can see what happened here, you guys. After we do those 3 multiplications, all right, remember to do the factoring and canceling if necessary when you're multiplying fractions. But after you do the 3 multiplications in the 3 red circles, it transforms the problem into either a linear or quadratic equation. Now, they're not going to tell you which one it is, linear or quadratic. You got to figure that out yourself. But we can do that because notice there's no brackets here. There's just a polynomial on both sides. As long as there's no brackets, all right, and I'll talk about when there is, all right. But if there's no brackets here, you just got to look at do we have just x or do we have x squared in the problem, all right? Well, clearly we just have x, not x squared, so this must be linear, right? Okay, so by the way, just a reminder here, you guys, why is it that this original problem here is not linear? All I see is x's, right? Like, I don't see x squared. Why is that not linear then? What's the difference? The difference is that when you have fractions in your equation, you guys, with variables in the bottom in particular, that cannot be polynomials right there. You can't have you can't say that something's a polynomial if you have a fraction with a variable on the bottom. And in order to be a linear equation or a quadratic equation, you need to have a polynomial on both sides after the parentheses or any parentheses you have are cleared out. Well, there's no parentheses here at all, but yet still we have the variable on the bottom of the fraction, so that cannot be linear. I just wanted to clear that up there. I didn't want you to think that this was linear somehow and that we should jump right into the linear steps. Okay, so fractions with variables on the bottom, it's neither linear nor quadratic, not yet anyway. We transform it into either linear or quadratic. We've now done that, and so let me finish off the problem. Since this is linear, I need to do my linear steps, which is to clear out any parentheses, which I already did up here. And then the next step is to combine like terms. I just did that with the 25 and the 2. I then move over the 27. All right, and then finally I divide out the 5. My final answer, at least initially here, I'll get into that, but it appears that the final answer is 6, right? Don't circle that yet. I want to talk about that. Whenever you solve an equation, you guys, solving a one variable equation, getting x by itself, solving for x, okay, if that equation has a variable in the bottom of a fraction, it is possible when you use this method or just about any other method you choose to solve an equation like this, it is possible that you're going to get an answer that actually makes one of your denominators equal to 0. And as we've talked about earlier in the semester, you cannot have 0 denominators, okay? It doesn't give you an answer. And so there's no way that something could be a solution if when you plug it in, it gives you some fractions that are undefined because you have a 0 denominator. So all you need to do to finish off this problem is take this answer 6 and just check it. See if it makes any of the denominators in the original equation that we were solving equal to 0. Well, if I plug 6 into these denominators, I get 6 minus 5 and 6 minus 5. Both of those denominators are equal to 1, not 0, and so we're just fine, okay? But you got to check that. And we're going to see some equations coming up here where when we check it, we are going to get some 0 denominators, and that's going to affect how we finish off the problem. We'll see that coming up. All right. Let's move on to the next problem, though, right now. Remember, when you figure out the LCD, which we got to do first in one of these problems, you have to, first of all, factor your denominators. All right, this one is already prime. This one's prime. And then this one does factor. It's x minus 3x plus 3. I'll put that into the denominator on the next step there. Right now, I'll just write it down right below it there. But what is that... give me for an LCD right there then? Well, there's no green factor, so you don't have to worry about putting that into the LCD. And then as far as the red ones, there's 2 different red ones, isn't there? There's an x minus 3 that appears a couple times, and there's an x plus 3 that appears a couple times. So as it turns out, the LCD is going to be x minus 3 and x plus 3. I just calculated that the same way that we did back in section 6.2 when we learned about LCD. All right. So what do I do? When you have 2 fractions this time, 2 fractions separated by a minus, this would also be true if this is a plus. What you do is you multiply both fractions individually by the LCD, and then you bring down the minus sign in between those 2 multiplications again. So this is, and please write this out, you guys, to avoid any kind of careless mistakes, because you have to multiply both of them by the entire LCD here. So if part of the LCD cancels out on the first fraction, you still got to multiply the entire LCD by the second one. All right. You don't just cancel some of it from the first one and then multiply the remainder of the LCD by the second fraction. No, you have to multiply both fractions by the entire thing. So I'm going to write this out to make sure that I don't miss any of that. So write out, again, make the LCD into a fraction if it's being multiplied by a fraction. Again, bring down the minus that's in between. And then, again, I need to multiply the LCD, which I'm going to make into a fraction, by this other fraction here on the left-hand side of the equal sign, like this. All right. Now, like I said in the last problem, when you have let me just pull it out here. Write it down here. When you have just a single fraction on one side of the equal sign, just like we did over here in this problem, you just have to multiply the LCD one time by that. Okay, just multiply by that. There's not 2 separate parts like in the left-hand side of the equation. Like this. Okay. And then with this, once again, as it oftentimes does, this once again gives us a total of 3 multiplications here that we got to do. We multiply the LCD by 3 things here. So I got to figure out what these 3 things are equal to when I multiply the fractions together in each of the 3 parts. When I do that, I will end up with a normal looking equation. So I got some work to do here, but then it'll be a pretty normal looking equation after all that's done. Again, and when I multiply fractions, I have to identify my factors here. I've got some reds and some greens here. What am I allowed to cancel here? The only thing that cancels is the x plus 3 and the x plus 3, right? since they're exactly the same, I get 1 and 1 right here. All right, let me zoom in there a little bit there. Okay, and now what does that give me here? Well, this is what we need to talk about that's really important. Notice that all I got left here, and you're always going to end up with 1 times 1 on the bottom if you do this right, okay? And that's what makes the denominators go away like I said they should. 1 times 1 is 1, and then the denominators will go away. But on the top, if you have a single term in one of your denominators, doesn't matter which one, and the other one still has a 2-term factor left over, in this case x minus 3, what I want you to do, don't multiply it together yet, in the sense of don't distribute the 4x yet. What I want you to do is put the single term in front like I hinted at the last problem. Okay, even if it's on the right-hand side right now, put it in front. Because when you multiply two things together, you can change the order. That's okay. You can change the order of the two things being multiplied. So I have what? I have 4x, which is the single term, and then the red factor over here. So if I've got a green factor and a red factor, all right, and everything else canceled, other than the ones there, then put the green factor in front and multiply by the red one. If you've got a green one in one denominator, or have a green one in one numerator and a red one in the other numerator, that's when you do that. Okay, because again, we want if we have a single term times a bracket, you guys, we want to put the single term in front so we can distribute it normally, like we normally do on the next step. Do not multiply this out yet. Don't distribute this out. Just say it's being multiplied. We will do the distribution of 4x on the next step. All right, very important in order to make sure that you don't get things in the wrong place and everything. Okay, so make sure to wait until the next step to do the distribution there. Similar thing is going to happen here on the next one. All right, we got a bunch of red ones here. Got a couple of green ones here. What cancels? What cancels here is the x minus 3 this time, and once again you can see that on the top I have left, not including the ones, I have a red factor and a green factor. A red factor in one numerator and a green one in the other. You're going to see that a lot. So once again, put the green one in front. Do not distribute yet. Very important, especially with a minus sign, but even if it was plus, it's still important. Okay, wait till the next step so that you can incorporate the sign in front of the 12 into the distribution like we normally do. All right, so bring down the 12 and the x plus 3 behind it. Green first and then red. Single term and then the multiple term factor after that. All right. Bring down the equal sign, all right, after that. And then on the other side of the equal sign, what do we got here? We've got all these factors. Now, notice that this thing right here, you guys, I can factor that. So normally, you're supposed to factor that if you can factor it in order to get this thing in lowest terms. However, I'm not concerned about lowest terms right now. I'm concerned about getting rid of the denominators and making them just equal to 1 times 1. So you don't have to factor this right now if you don't want to. We're not concerned about lowest terms here. We're just trying to solve the equation. Okay, so you can see here that if I cancel all of these, which I can, I'm going to get ones on the bottom, and that's it, right? 1 times 1 times 1. So that's going to give me what I want. I want the bottom to be equal to 1. And so as long as that's the case, you don't have to factor anything on the top right now, okay, if you don't want to. You can, but you don't have to. All right. And so, again, not trying to put it in lowest terms, all right? Normally you would when you're multiplying fractions, and that's why you're supposed to cancel everything you can and factor everything you can and all that stuff. But again, our goal here is just to make the denominators equal to 1 so that the fractions will go away, at least on this step. So you can see here that since everything else is ones, we end up getting 4x squared plus 36, okay, because that's being multiplied by ones right here, and then the bottom is 1 times 1 times 1. So it's just going to be equal to that. When you multiply by 1, it doesn't change. It doesn't change it, okay? It's still going to be this right here. So we got ourselves a normal-looking equation again. It appears that we have a quadratic equation. Let's make sure, all right, whether it's linear or quadratic, at least for the time being. We'll see other methods later, but we normally get rid of the brackets first here on this next step, whether it's linear or quadratic, and then at that point we look at it and we go, oh, it appears to be quadratic because we got x squared instead of just x, right? But this is kind of a special problem here. It's kind of rare, but sometimes just because something looks quadratic doesn't mean that it is, because if I move the 4x squares to the same side, which you normally would in a quadratic equation, wouldn't they cancel here? Okay, normally you'd move everything to one side in a quadratic equation, but I can tell here that these are going to cancel, so it's not even quadratic. So that's something that's rare that happens. So once you realize that, you just got to change gears here inside your mind, and you got to say, oh, it's really linear, isn't it? And since it's linear, now that I've canceled out those x squared terms, I just need to do the linear steps now. And that means to, since the parentheses are already cleared out, I'm going to combine like terms. And then I'm going to move over the 36 with the other 36 there. And that's going to give me, when I add that over, I'm going to get negative 24x is equal to 72. And then finally, if I divide out by negative 24, I get x equal to negative 3. Stop right there, you guys. Don't circle that yet. Okay, remember, we got to check our answer. But hey, look at this, though. Remember, none of your denominators can be equal to 0. Okay, none of them. If any of them are, then this is not going to work as an answer, because you can't have a 0 denominator when you plug in the solution into the equation. All right, it's got to be something that makes the equation true when you plug it in. If you have a 0 denominator, that means that part of the answer is not even a number. It's not even a defined number. It's undefined, and so it therefore can't be a solution. So does that happen here? Yes, it does. You can see that on the very first denominator, in fact. If I plug in negative 3, I get negative 3 plus 3 is 0 right there. Okay? So if it makes any of these denominators equal to 0, you got to throw it out. What happens, though, if you get only one answer given to you, negative 3, and it's not an answer? What do you say? You have to say these two words that we've said a number of times in the past: no solution. So if you have no answers left after you have checked your answers, you got to say those two words there. Don't just cross out the answer and think that that's acceptable. If you just cross out the answer only without saying these two words, I'll think that you may not understand that there really isn't any other answers hidden somewhere. All right. But by saying these two words, you'll be confidently declaring to me that, yeah, there really is no solution. All right. In other words, the method that we're doing here will always give us all the good answers. It always will. So if the only answer that it does give us is bad, that must mean that there are no good answers, because this method will always give us the good answers if there are any. So since there's no good answers left, that must mean that there are no good answers. Okay, let's try one more here before you guys take your turn and try it. Problem C. The LCD right here is what? When you have just a constant number and then just x as your other denominator, 2 and x, the LCD will just be those two things multiplied together. We saw that in the complex fractions section, 6.3. We saw that a few times. Okay. So yeah, if you have a constant and then just x with no coefficient with the x, it just merges together. That's just something that happens in that case. It'd be nice if you could always just multiply the denominators together to get the LCD, but unfortunately, that's not always that simple. But it is here when that happens. So like we said in the previous problem, if you have two fractions with a minus in between it, what you're supposed to do is you're supposed to multiply both of those by the LCD, like this, keeping the minus sign in between those two multiplications. So 2x over 1 times the first fraction, 2x over 1 times the second fraction, keeping the minus sign in between. And then when you are multiplying by just a term, and if you have just a term on one side of the equal sign, multiply the LCD by that, but you don't need to make a fraction out of the LCD when you're not multiplying by an LCD, or by a fraction. It's just when you're multiplying by a fraction that you want to the LCD into a fraction also. So since the 1 is not a fraction, no need to put 2x over 1. You just got to say 2x. All right. So again, we want to do these 3 multiplications. All right. What do they end up being equal to? Notice it in each one of these 2 pairs of fractions, right? These 2 right here. Okay, everything is just a single term, the 2 numerators and the 2 denominators. So no factoring is necessary. You can jump right into the canceling. What do we cancel? The 2's on this one right here, and that's going to lead to, isn't that going to lead to x squared over 1, which is x squared? All right. And then bring down the minus. Okay, this time you cancel the x's, and we end up with 2 times 1 is 2, and then times 12 is 24. 24 over 1, as always, the bottom should be 1 if you did it right. And so you just get minus 24. Bring down that equal sign, and then 2x times 1, of course, is equal to 2x. Okay. What kind of equation do we have now that I've gotten rid of the fractions, you guys? Is it linear or quadratic? Well, clearly it's quadratic because of that x squared, and we can tell it's not going to cancel with, because there's not another x squared here that it could cancel with. So what we need to do, since it's quadratic, is we need to do the quadratic method, which is to move all the terms to one side. But when you do that, remember to move it in such a way that if you have an x squared term, an x term, and a constant term, which we do, we have all of those, we want to move it so that the x squared will stay positive. All right, so that means we want to move this over and not to move the x squared over to the other side. We want to keep that x squared positive if it already is. Also remember to put it in this order right here when you move it all over to one side so that you can do the Berry method. All right, what does the Berry method say? It says that 1 times negative 24 is negative 24. And then we need a sum of negative 2. What 2 numbers add up to negative 2? There would also be factors of negative 24. That would be, how about negative 6 and positive 4? All right. So we have x minus 6 and x plus 4. The last step of the Berry method does not need to be done because the GCF of each bracket is 1. That's not going to change anything. So as I do when I solve quadratic equations, I need to set both of these factors, both of these red factors equal to 0 and solve those factors. What do I get? I get, if I move over the 6, I get x equal to positive 6. And if I move over the 4, I get x equal to negative 4. Don't circle that yet. Now remember, we still got to check our denominators. If you have a denominator that does not have a variable in it, you don't need to check that one. It's just the ones that have the variables in it. All right. So just this one. And since that's just x, whatever number you plug in is going to be what the denominator is equal to. If I plug 6 into here, the denominator is 6. If I plug the other number in, negative 4, that denominator is negative 4. The important thing is that the denominator is not equal to 0 in either one of these 2 possible answers. And so that's why I'm allowed to circle both of them confidently, knowing that neither one of them caused that issue where sometimes the denominator is 0, like it was in the last problem. So circle both of those, and that problem is now complete. Okay. I'm going to go ahead and get you guys started on the next one here. I'll let you finish it, all right? And then I'll let you do number 2 and number 3 as well here. Notice that our 2 denominators that we have are both prime, aren't they? Okay. And so what would be the LCD when that happens? Okay, the LCD in that case would be just the those 2 things multiplied together. Let me write that down off to the side here. Okay, because you got to put all the different red ones into the LCD. Here it is right here. Okay, just make sure we are organized right here. Separate those 2 problems. There we go. So now I need to multiply both sides of the equation by the LCD. Since we have 2 fractions on the left, separated this time by a plus. It doesn't matter if it's plus or minus in between those two fractions. You need to multiply the LCD by both of those fractions, and then if there's a plus or minus in between it, you bring that down in between. In this case, it's a plus, like that. So listen, let me multiply the other one by the LCD as well here, that second fraction. There we go, right there. And then the equal sign comes down as well. Now, here's the thing. Again, when you multiply it by a term, you don't need to make the LCD into a fraction. But because that's a single term, and because the LCD has brackets in it, put the single term in front of the brackets. Okay? But that's what's different about this problem compared to the other three problems we just did. And we've seen this before, we just haven't seen it in this section. Notice in this third thing here that I got to multiply, I'm just circling the three things I got to multiply together here. But notice in this third thing here, we have a term times a bracket times, sorry, that fell off the screen there. We have a term times a bracket times another bracket. Okay, put that single term in front of those two brackets. All right, like we talked about. Now, how do you do that, though? How do you multiply that out? Well, we learned that back in section 5.2. Let me just look at that real quick. All right. Just clean this up here so it's easier to see. Okay. When you multiply a term times a bracket, you got to do just the term times the first bracket first. Get that answer, put it in parentheses, and then multiply that by the second bracket, and then that gives you what you need. All right. And so I'd like you to do that same thing right here in this one. Also multiply these two things together, doing the necessary canceling to make the denominators equal to 1, all that good stuff. All right, so go ahead and try that. I'll look at those answers in a moment, along with the answers for problems 2 and 3 down below that. All right, so go ahead and try those problems and then hit play after that. Okay, looking at those answers right here, we got these three things that we've got to deal with that we just talked about. Multiplying out the one on the right here, we end up getting 3x squared minus 6x plus 3x minus 6. And so that would go on the right-hand side of the equal sign. Okay, I'll write that down in the next tab here. I'm just pointing at it right now. Over here, the x plus 1's cancel. All right, and remember what we said. When you have a green one and a red one left over on the top here, put the green one in front. Okay, don't distribute it yet, not until the next step. Bring down the symbol in between the two red circles here. In this case, it's plus, not minus like it was before. And same thing here. After we cancel, we end up with a single green one and a single red one on top here. So put the green one in front of the red. And don't distribute it yet, and it's all set up for you. So we got these two. We got this thing right here on the left. We've got this thing over here on the right. Okay, I kind of ran out of space here to write that, so I just pointed to it. On the next step, though, we end up getting, after I distribute, which I should always do first, after I get down to that step where I need to, and I've gotten rid of the, after I've gotten rid of the fractions and everything, distribute if you still have parentheses. Okay, and we get this right here. Once again, just like in problem B, all right, it looks quadratic, but the 3x squares, if you try to move them to the same side like you normally would in a quadratic, they're going to cancel out. And so we just change gears once again, and we treat it like it's a linear equation, which, because it is, because the x squares went away. So we combine like terms. We then move over the x's to one side and the constants to the other. Again, all the same stuff you normally do in a linear equation. And that would actually get x by itself when you move the 3x over to the left. 1x equal to negative 10. So you don't need to divide out this time. I went ahead and circled that answer instead of crossing it out because negative 10 does not make my denominators equal to 0. It makes this one negative 10 plus 1. That's not equal to 0. Negative 10 minus 2. Again, that is not equal to 0. So that's number 1. Number 2. Okay. Number 2. Our LCD right there has to be figured out by, first of all, looking at the denominators and factoring them, the first denominator still needs to be factored. You can see here that after you identify all your factors and all of your denominators, you get what here? You've got a couple of 5s. There's a couple of green factors there that I underlined. I know that looks like it's darker than green right there, but it's meant to be green. So when you got a couple of greens and a couple of reds in your denominators all together amongst all of the factors that you found, that is going to be so that you need to do the greens separate from the reds. Okay. And so what is the least common multiple of 5 and 5? You got to do that first. Well, since they're both the same, the least common multiple will also be 5. So we got to put 5 into the LCD. And then you got to put all of the different red ones in there as well. But since both of them are the same red one, you just put that single red one in there. Okay, because there's only one different red one, even though there's 2 that we see here, due to the fact that they're both the same. So this right here, you guys, is the thing that you multiply by each side of the equation. Again, if you have just a single fraction on one side of the equation, multiply the LCD by that, okay? And you can see it's hard to see that because of all the cross-out marks, but I'll help you out there. The LCD's right here. The current fraction is here. Then when you have 2 fractions with a minus in between it, like always, we multiply both of them by the LCD, keeping the minus sign in between. Once again, we have 3 red circles here. In other words, 3 things we got to multiply together. It will then become a linear, or not necessarily linear, but it'll become a regular looking equation after you do these 3 multiplications, and all of the denominators will become 1. You can see that happens here. The 5s cancel, the x plus 1s cancel. Please put your denominators in their factored form here when you bring this down, because you're going to need to factor that anyway before you cancel. All right. This is not one of those situations where you don't need to factor, like I said on a problem earlier, because I need to factor this in order to make these denominators equal to 1. It has to happen, and I need to keep my LCD in factored form as well, because again, you'll need to factor that too if it wasn't already in factored form like it is. Keep it that way so that you can cancel as well. Okay. Keep moving here. But anyway, what does this end up being equal to here? This first red circle, it is equal to 1. Okay, because everything is 1s here. 1 over 1 is equal to 1. Then in the second red circle, the x plus 1s cancel, and now I have just a couple of green ones, not including the ones that are left over. I just have a couple of green ones. When that happens, you guys, you can just multiply those right now. I just told you earlier to not multiply yet if you get a red times a green. Okay. In other words, there's at least one red one left after you're done canceling on the top. Then just bring it down, like we said in that last problem right there. Bring it down, the red one with the green one. All right. Don't multiply it yet, because you got to be careful about how you distribute that and everything. So if you've got at least one red one left on the top, don't multiply it yet. But since these are both green, 5 and 3, it's just equal to 15. Okay. And then the last part here, bring down the minus. The 5s cancel, and we got that red and green situation again. So put the green one in front of the red. The green one in front of the red. Very important, so that you can then distribute the 7 along with the minus like we normally would there. Okay, so put that 7 in front, the green one in front of the red. That then leads to a normal looking equation. After we distribute, it becomes clear that this is a linear equation, because you don't have x squared, you just have x. And then we do all the linear steps. Combine like terms. Move over the 8 with the 1, as you can see there. And then when you divide out the negative 7 like you normally would, you end up getting x equal to 1. All right. Then we plug in the 1 into our denominators to see if there's an issue with the denominators. There isn't, because the original denominators will be equal to 5 times 1 plus 5. That's not 0. I don't care what it's equal to as long as it's not 0. If I plug 1 into here, I get 1 plus 1. That's not 0. And then this one doesn't have a variable, so you don't have to plug it into that. So that's why I circled this. I knew, and I checked it to make sure that the denominators were not 0. All right, now, last one here, number 3. Okay, number 3. Let's take a look at that. The LCD ends up being equal to x plus 1, x plus 3 because the last denominator ends up being factored down to that. And so we end up getting 4 red ones, but there's only 2 different red ones. And so that's why the 2 different red ones go into the LCD. All right, just like we've done before in the past with the LCD in this type of situation. And as we know now, when you have 2 fractions on one side of your equal sign, like we do on the left here, separated by either a plus or minus, in this case minus right here, we multiply both of those fractions by the LCD, keeping the minus in between that. And then if you have just a single fraction on the other side, let me zoom out a little bit. There we go. If we just have a single fraction on the other side, we multiply that by the LCD as well. Just that one fraction. So again, we have 3 multiplications like we oftentimes do. Figuring out these 3 multiplications, I get the following here, right here. Okay. Again, green in front of red. If you have 1 green and 1 red left on the top, green in front of red. Bring down the minus. Okay, in front of that, okay, in front of that second part there. All right, don't distribute yet. This is a normal looking equation. After I distribute, it becomes clear that it is a linear equation. And so let's finish off that problem there. What is it going to end up being equal to? I combine like terms after I distribute in a linear equation. I then move the x's to one side and the constants to the other, like always, in a linear equation. And then finally, I divide out. If I divide out, my final answer is going to be x equal to -3. But why did I cross that out, you guys? Why did I cross out -3? Because if I plug in -3 into the first denominator, it makes it equal to 0. -3 plus 3. That it doesn't even matter what the other denominators are. If one of the denominators is 0, you throw that answer out. And since that was the only answer that the problem gave me, that means there are no answers that are good. And so we have to say these 2 words, just like we did in problem B right up above it. Okay, you need to say those 2 words if there are no good answers left after you've checked your answer. All right, so that concludes how to solve equations that have fractions in it, in particular fractions that have variables in the bottom. Okay, although oftentimes you can do this you can do the same method even when there aren't variables in the bottom. Okay, but it just depends on the situation. But this is the method you want to do here normally when you do have variables in the bottom. All right, so as usual, let me know if you have any questions about that, and certainly this will help us with the next section. But first things first, let me know if you have any questions about this, and you have a good day.